Okay, so I've just checked on YouTube, and I've got a question there from Melindu, and he's asked me, can you explain polymorphism using a car parking system? Okay, I've got a project to complete. So that's all he said. So now, if this is an assignment, I'm not ever going to give you a solution to an assignment, but I'll get you start to think about polymorphism in terms of car parking. So I'll probably put some class headers in and a little bit of detail, and but I'm not going to flesh everything out. I'm just going to get you started so you can think about car parking in terms of polymorphism. Okay, so we might have a car park class, and in there might be charge per hour. Okay, and that'll be a double and a private. And I'm not going to. It's not a complete class. I'm not putting opening braces in and everything. I'm just doing a quick sketch out of how things might work. Okay, so you might have a charge per hour. You might also have a charge per day. And you might have the number of car parks. So private int number parking spaces. So you might have, 100 parking spaces, and the charge per day might be maybe $10 a day, and the charge per hour might be $1.50 per hour or something. I don't know, whatever it is, So that's the sort of thing you might have. So you'd have suitable constructors. So you could create car park objects, and you'd have accessor methods. Get charge per hour, get charge per day, get number of spaces, that sort of thing. You'd have mutators to change the charges if you needed to. You'd have a toString method. So all the usual things we have when we create a class. Just think of it like baking a recipe. Okay, so they're the sort of things you'd have for your car park class. Now, that's fine. And that's a class. So we could now create car park objects if we had a main program. We could do things like car park, my car park, or Smith Road car park equals new car park. And if we had a constructor that took these three fields, we could put in the charge per day, which is $2 per hour. The charge per day is $12.50, and the number of spaces is 120 spaces. Okay, so I'm assuming we've got a constructor here that would be able to handle the data like this. Okay, so I'm assuming you know all about that if you're asking about polymorphism and that. So we're getting on to the next level of Java now. So what else could you do? What else could you do to maybe get polymorphism to work here? What about if you had different types of car parks? So you could have maybe a secure car park, okay, with a security fencing, okay, and security guards, and you could have an outdoor car park, and these could both extend car park, okay. Extend car park. So these are this is a subclass of car park, and this is also a subclass of car park. So you could have different types of car parks. Okay, and so what would a secure car park have? Well, it would have so we'd have a double private, maybe extra charge per hour. So in other words, the extra charge on top of the normal charge per hour, and you might charge an extra $2 per hour. Okay, so on top of the normal charge per hour, which is $1.50, if it's a secure car park, you might charge $2. Okay, or $2.50. Okay, so you might also have charge per day and number of spaces in the secure car park, but these are all things that are up here. So you don't want to duplicate all this down here in your secure car park. You just want to put the things that are new. Okay, so the extra charges that apply per hour. Okay, so it's $1.50 for the base charge and plus $2.50, so it'll be $3 or it'll be $4 for the secure car park per hour. Okay, and what else could you have that might make a secure car park different? So you might have a limited number of spaces, of course, but that's all stuff that's stored up here in the superclass. So the extra fees, basically, the extra fees per hour. I'll call that extra fees per hour. You could have different levels of secure parking. You could have levels where private int number security cameras, and you might even have a number of security guards that are on duty. Okay, so you might have all data like that, and so one really secure car park where people park their Ferraris and their Lamborghinis, all the rich people go, that might have 20 security cameras. Okay, and it might have 3 full-time security guards that patrol all around the car park all day and all night. Okay, so that's a really good secure car park, maybe. Okay, so you could charge a premium for that. You might be able to charge an extra $10 an hour because only the rich people could leave their cars there and they can afford it, so charge them. And then maybe you might have an outdoor car park. And, so what could an outdoor car park have that makes it different from the parent class? So you've got to just think about things maybe, you might have number of trees. I don't know, I'm just trying to make things up here. I'm just trying to think about how things could work. So you might have a number of trees. So if you've got a car park with 100 spaces and 100 trees, you're probably guaranteed to get some shade on your car. If you've got a car park with 100 spaces and only 5 trees, maybe the shade's going to be more limited. Only a few spots will have shade. So maybe you want to keep track of the number of trees in a car park, maybe not. Okay, so again, you would have for each of these classes, you'd have constructors, accessors, mutators, and a 2-string, and so on. And also for this class, you'd have suitable constructors, mutators, and 2-string, and so on as well. So whatever other methods you use to providing, the equals method's a good one, and so on. So then you could create other car park objects. For example, you could create a secure car park. And that might be on, we'll put that one on Posh Road. Posh Road car park. And we're creating a secure car park. And so here we want to pass through, normally you pass through to the constructor all of these fields, and also the values for these fields. Okay, so the base parking, the charges might be that, and there might be just 25 spaces. It's a very exclusive. And what are the extra fees they charge? So now we're passing through these values. The extra charge might be $2.50 per hour. So the total per hour would be $4.50. Okay. And we want to pass through the number of security cameras. So this car park's really secure. It's only got 25 spaces, but there's 20 cameras in it, and there's only 1 security guard. Okay, it's only a small space, only 25 car parks. And then we can create also an outdoor car park. And again, we're going to pass through the values for all of these parent class fields, plus the ones that are unique to the outdoor car park. So this would be Park Road car park, just making up car park names, equals new outdoor car park. And again, we want to pass through all these fields. So this is outdoors, so it's going to be cheaper. It's $1 an hour. For a day, it's only $6 a day. There's 300 spaces. And how many trees are in the car park? We'll only have 5 trees. Okay, so do you see where I'm going? Once you build the parameterized constructors and things, you'll see how I'm just passing through the values. So now let's talk about polymorphism. How does the polymorphism work in here? Okay, so let's have a look at that. So again, we're still in our main program here. This is still in our main. Okay, so let's do some polymorphism. Let's create an array of car park. And we'll call it car parks equals new car park. So we just use a plain old array. You could use an array list or a linked list or whatever you want to do. And we'll have 10 car parks in our array. So this might be a company that owns a lot of car parks around a city or around, wherever, around a region. And now we can create car parks in our array. So we could say car park 0, which is the first car park, equals new car park. So we could just make that just a standard car park. Just grab that up there. 1 equals sign, that's all we need. Okay. So I'm just going to use these same details here. So car park 1 and car park 2. And we can store these details in the array as well. Okay, so instead of having the car park stored in separate objects, I've now got them stored inside a single array. Okay, and that's really great. Using arrays is great because you can loop through data and load it all into the array from a database or file or from user input, and you can loop through the array and write it all out to file much easier than you can with individual objects. Individual objects are really awkward to manage. Arrays are much easier to manage multiple types of the same sort of data. Okay, and this is now polymorphism in action. We've got a car park that at times is a real car park, or at other times is a secure car park, which is a special type of car park, and also an outdoor car park. Okay, so if we want to loop through and display all car parks to the screen, we could do it with a loop for int k is equal to 0, k is less than car parks dot length, the length of the array, k plus plus. Okay, and then we could go system dot out dot print line. We could get the details for the car park, so car parks k dot get. We'll just go toString. We'll call it a toString method. Okay, so I'm assuming you've got implementation there for the toStrings in each class and up there. Okay, so that would print out the details for all car parks. If you wanted to display just the secure car parks, you could change this slightly. Okay, and so you could do an is-a test if car parks k is an instance of a secure car park, then you could display the car park to the screen. So here we're listing just the secure car parks, and that's where instance of comes in really useful. You can check what it is. All of these are still car parks, but some of them are secure car parks, some of them are outdoor car parks, some of them are just standard car parks. Okay, and this is all polymorphism in action. We've got multiple types of data: car park, secure car park, outdoor car park. They're all stored in one array, and because car park is the parent of all classes, we can store these other types of car parks in the same array altogether. Okay, so that's basically how it works. I don't want to really go any further because I don't want to give you the answers to an assignment or something like that. And it's important that you think about these things because you're going to be building on them in future weeks. So I hope that was useful. And Melinda, and good luck with things. The whole trick to getting comfortable with all of these topics is to write lots of code, explore lots of problems, and write lots of code. So look at the back of your textbook at the end of each chapter, and solve all the questions in there, and do all the tutorial questions, and pretty soon this will all become second nature. Okay, so I hope that was useful. Thanks for watching. Have a nice day.